Good morning. Going to go through the skeletal system today. Kind of gone over the integumentary system, so now we're going to hit the next major system, which would be the skeletal. So we've got about 206 bones in our bodies. That's including the 6 bones in your ears that you've got 3 on each side that make up your inner ear. So bone formation will start when you are a fetus and will continue until you're in your adolescent years. So you're always making more bone, which is pretty evident because you get taller. So, okay. Couple of functions of the skeletal system. It's going to provide your body with support and protection for your body. So, going to protect those organs like your rib cage, and then it's going to also help you give your body its shape. Without your bones, it'd basically be a big pile of skin and organs. We wouldn't really have an actual structure, if you will. So another thing that your skeletal system is going to do is it's going to allow your body to move. So your muscles are hooked into your bones. So without that, you're not going to be able to move. They provide that anchor. So we'll talk about these later, but a joint is a place where 2 bones are going to meet. So your joints are going to basically act as pivot points for your body to move. So 2 reasons there. Those are some of the major well-known functions. Another one that's obvious, but we don't always think about, is that your skeletal system is going to serve as a mineral reservoir. So it's going to store important minerals like calcium, phosphorus, potassium, magnesium, carbonate ions. Mostly it's going to store your calcium. That's the big one. So the reason why calcium is so important is it's going to help your body in terms of it's one of those necessary minerals rather that your nerves and your muscles need to be able to function. So it's needed to go through their chemical reactions so that they can have the ability to contract, so that they can have the ability to transmit nerve impulses. So what happens if your calcium, your skeleton's pretty neat, but what happens is if you have too much calcium in your bloodstream, That excess calcium will then be directed towards your bones, and your bones will go ahead and store it inside of those bone cells. And then when calcium levels get too low, those bone cells then will get broken down, and then the calcium will then be deposited into your bloodstream and taken around to wherever it needs. So it's a really interesting phenomenon that your body does. So to help maintain the proper level of calcium in your body. Another thing that your skeletal system is going to do is it's going to produce blood cells. It's called hematopoiesis. You might have known that your skeletal system does this, but basically, your bone marrow is there to produce your blood cells, your red and white blood cells. So my guess is you've also heard of a bone marrow. It's kind of a soft tissue. So it's not quite like stem cells, but it generates your new blood cells. So your red marrow is going to produce your red blood cells. Your yellow marrow will produce your white blood cells. I think I tell you that later, though. You do have some stem cells in there because those particular cells can generate red or white blood cells. And then, in case you did or did not already know, there's different offshoots of blood cells. So there's very specific white blood cells. They have different names that they go by. There are three major types of blood cells. You have these cells called osteoblasts, and they are young bone cells. They are so those minerals. It's going to store them in this kind of, I don't want to say embed it into the matrix. So the next type of bone cell is going to be your osteocyte. Your bone cell that's not secreting matrix. It's technically still alive, but it's just not making any more matrix. So I mean, it's basically a storage cell at that point for your minerals. So it's not taking in the minerals and storing them. It's just storing them. There's nothing else happening. And then your last type of bone cell is called an osteoclast. those types of cells are going to break down your osteocytes. So when your calcium levels are low, your osteoclasts kick in and start breaking down those osteocytes that have the calcium and other mineral deposits embedded in them. And so the osteoclasts break them down so that way the minerals can be released into the bloodstream. Okay. We're going to look at the long bone now. There's a couple of different parts to it. The first being the compact bone. This is the outer layer of the bone. Not the outer covering, but it's going to make up that inner shaft of the long bone. So okay, your spongy bone, that's going to be found at the top part of your bone. It's going to be exactly what it sounds like, spongy looking, so it's going to have like holes and stuff in there. So I don't know how well you can see the picture here, but the compact bone is going to be here on the inside or the outside there, and then your spongy bone is all of this holy looking bone. So it does look holy and it does have holes in there. That's why it gets its name from spongy. So then you've got cavities within there. It's a very big cavity here, so I don't know how well you can see this, but the spongy bone only goes down to about here on the long bone here. So, oh, by the way, long bones, we're talking like your femur. So then there's this big empty space here that goes space here in between, and that's called the medullary cavity. And that structure is going to house your marrow. Specifically, it's going to house your red marrow. And then your yellow marrow is generally it's up more towards embedded in with the spongy bone. So, and like I said earlier, the yellow marrow is going to produce your white blood cells, and then your red marrow is going to produce the red blood cells. Few more things on the long bone structure. At the very, very top of the joint, or I'm going to call it a process that kind of sticks out. Not technically a process. A process, by the way, in anatomy speak, is anything on a bone that sticks out. It's a process. But it's basically the head part of your bone. So like this right here. So your articular cartilage is going to be right about here. So, and its job is to give some cushion to your bones. So when your bones are moving, so when that arm is moving, the articular cartilage is there to kind of provide some cushion for those particular bones so that they don't grind up against another bone. So then you've got your epiphyseal epiphyseal discs or plates. These are called your growth plates. So they're usually going to be located here and here. So they can produce more bone cells. That's what allows you need those in your long bones, because that's what's going to allow your legs to get longer, your arms to get longer, your fingers to get longer. So that's how you get taller. So if you've ever heard of the growth plates, that's pretty much what they're talking about, is the epiphyseal plates. So then the outside covering of your bone is called the periosteum. So that would be the outer covering that surrounds even over here. So you have your compact bone, the outer layer over here would be your periosteum. So I got a better picture. I guess I just didn't think about that. So I've got a better picture here of your long bone. So you can see the periosteum, which is that outer covering. Right directly underneath it is that compact bone. And then, sorry, I got it backwards. Your yellow marrow is here on the inside, and your red marrow is up here. I switched it. Because you're generating blood cells, you're also going to have blood vessels running the length of this inside of the medullary cavity, that big empty space. You got your spongy bone up here, and then your epiphyseal discs here and here. It's not really pointing to the right spot. It's actually right here. And then you've got your articular cartilage on the outside. So the proximal epiphysis, the diaphysis, and the distal epiphysis, they're just talking about what area of the bone. The proximal epiphysis is going to be closer, obviously, to the torso, so closer to that shoulder joint. And then this would be closer to your elbow. Distal makes sense. So last little bit here, we have, if you were to break down your compact bone, you would have, it's not really a cell, it's a functional unit. So it's kind of like a cell, but it's the smallest functioning entity in the compact bone. So I call it a functional unit. So they're going to have the osteocytes, those cells that are housing the minerals. And they're also going to house these things called caniculi. So these are going to be central canals that are going to allow nutrients to pass through them. So, which I've got a picture here in just a second if this doesn't make sense, which it might not, and that's okay if it doesn't make sense. So we've got your central canals also. So these are going to allow for the blood vessels to pass through. They're also going to allow for any lymph vessels and lymph to pass through. It's going to allow nerves to go through the bones. So obviously there's nerves because it hurts when you break a bone. So, and then these perforating canals are going to connect your central canals together. So like I said, this probably doesn't make a lot of sense yet, but here's the picture. So you have your osteum with its caniculi, the different canals that allows all your nutrients and stuff to get through. So you have your osteocyte or your osteon, okay, and that's going to have be made up of those osteocytes, okay. Square in the middle there is your central canal. It's right in the middle. You can see that your osteon is made up of different layers. So it's made up of lots of osteocytes. Okay, so we're not really going to say that it's made up of one single osteocyte because it's in fact it's many osteocytes. So, and then you've got your central canal going through, and the red, it would depict an artery. Your blue would depict a vein, and the yellow would note a lymph vessel to transport the lymph. This would also be technically where your nerves would also be able to go through. And then these perforating canals are going to connect your central canals together. So you can see that the osteon right here has a couple of different layers, and all of this is made up of those caniculi and osteocytes. Just a little bitty spaces in between the osteocytes, and all together they're like, so they're making up the osteon there. So, and then on the side here would be the periosteum, and then on the inside would be the it might be spongy bone, it might just be the inside of your medullary cavity. So I don't know how you can tell, but it's taken like this little piece right here, and then it's a side view. So that basically wraps up your skeletal system. Tomorrow I'll start going over the bones with you, so that'll be a lot there, but I'm not sure if you've learned those body parts before, but usually people have, if they've learned the skeletal bone names, they haven't necessarily taken apart the skeleton as far as we take it apart. So if you do have any questions, please don't hesitate to ask. Otherwise, have a good day.